So PCBs affect workers, public environment, everybody. It affects everybody. All right. With that said, let me get this thing up and running here. Any comments or questions left over from yesterday or the last 3 days? This is the last module of the awareness course. Anything left over from the past couple of days? We had some pretty good discussions. You want to get me excited and leave me feeling good at the end of the day? You just chat about PCBs. I thought we had a pretty damn good couple of days so far. Wayne, you got anything you want to throw in?
No, I'll save it to the end.
Okay.
See what we got.
You mean the end of today or end of tomorrow?
No, the end of the day, probably.
All right. All right. So I did do some research. I'm going to have to reach out to some of my colleagues that broach the environmental engineering world and the occupational world a little bit. So there's not a lot out there as far as, unfortunately, requiring an employer to test the stuff. And again, I did see a lot of information explicitly written up from news articles and journals. On the federal level, do not have to formally test for PCBs at any given time. No requirement. There's a lot of the phrase recommended and should, but nothing that is a must or shall, which is tough because what this means is unfortunately, this is going to come back to the union. We got to make sure that we educate members about this stuff and then be ready to back them up, because the only way to do it is to bring up the potential for an airborne hazard and then a contact hazard, if they're doing demo and stuff like that, which case then the employer would have to, at least do airborne personal samples to see if they're superseding the PELs. This is an interpretation letter that came out in '92. It was the second in a series by the same questioner. What they basically said is, yeah, there's no requirement to test. However, if the workers are going to be doing something that could expose them to PCBs, then they at least have to give them HAZCOM training. And the way the letter was written, I actually didn't agree with it because they told the questioner if they're PCBs in enclosed light ballasts, because this was specifically about removing light ballasts, you don't have to give HAZCOM training concerning PCBs, which blew me away because you don't know if they're going to be leaking until you take the damn things out of the lights, right? Am I wrong? So usually OSHA is very good at using the word potential for or if, right? To give the scenario. It doesn't have to happen, but if the probability, if there's a risk there, if there's a likelihood there, if it could happen, you got to do X, Y, and Z to make sure that your workers are ready to be protected. And with this case, again, you're not going to be knowing if these things are leaking until you take the covers off the lights and you start to disassemble them. One of the reasons why PCBs get discovered in lights is because the ballasts start leaking and stuff literally drops off a teacher's desk. So I'm not a fan of this letter. However, it did, say that if a worker could be exposed, then you got to at least tell them about it through the HAZCOM requirements. However, they gave the example that, removing ballasts, you wouldn't have to necessarily do that. Anyway, that was one of the letters that I found out there, but there is no clear cut and dry requirement that testing for PCBs is done, either for worker protection or for public health on the environmental side. So what we're left with is a good trained workforce and a good trained union stewards. And, if there's an avenue for us to train our contractors, that's good. And this is why it's good. So this is that example. I don't know why the heck I couldn't find this thing yesterday. I Googled everything to the dark web, finally found it this morning. Might have been because I was having coffee this morning. So this is the Cannon House office building in DC. This is just one news article from Roll Call that covered it. There's a couple other news articles about it. It actually had to go through in front of a congressional a testimony to find out why it's not done yet, why it's so far over budget. Anyway, so there's this office building that they're renovating. The final price tag might be more than $100 million. And I think 4 years past its due date. Why? Well, nobody had the wherewithal, apparently, to think that there may be some old hazardous materials in a 100-year-old building. And it's not just PCBs, although PCBs is one part of the cost matrix of this. Also lead and asbestos, as you could imagine. But just removing, abating the PCB caulking from the outside of the building facade was $100,000. And one of the environmental consultants in this news article actually said, I'm not surprised that they found it. I'm not surprised that the project managers didn't think about this in the beginning, but the person was surprised that this was done so cheaply, that they could do it for $100,000, because he said that this was, in his estimate, a very low price for removing that amount of PCB laden caulking. So there's a lot of, and there's a bunch of these kinds of stories, not that are this high profile, like with the DC building, but it really behooves a contractor if they can go in, with the understanding of what they might be facing. Because I'll tell you, it wasn't good for the associated contractors with this project, because all of a sudden all their work got shut down and they're waiting, right? There's mobility time. You got to stage your stuff there. You got to bring your equipment to a job. If it's just sitting there, it can't be used for something else. So this is, it's a win-win. It's a win-win for us as labor. It's a win for, contractors. It's a win for a project owner or building owner. Because they're not going to be hit with surprises, and you can be hit with surprises after the fact, like this showed, but it can also be farther down the line if they catch that a project removed PCBs outside of the standards of care and professional practice, and contaminated soil, the building, exposed the public, etc. It can be a big mess after the fact. And in land transfer, property transfer, you might have heard of the term due diligence. So, I've done work for industrial hygiene work where I would go and do investigations on like oil tanks and things like this, and potentially hazardous building materials like asbestos, PCBs, where a building owner is trying to sell off a property. A buyer wants a due diligence done. They want to do a check on that property to make sure there was no leaking underground storage tanks. There was never any spills that were, attended to. It doesn't have material in it that's going to cost them a lot of money. Or if it does, they want to know so that then they can adjust their price. So due diligence is important, and PCBs often gets missed in it. It hasn't gotten historically the same level of attention as, say, asbestos or lead, but it is now. Again, especially there were so many news articles just when I Googled PCBs in the news. I didn't know what to choose. I had analysis paralysis. There's too many choices in front of me. Like when you go down the cereal aisle, what the hell do I choose? So this is a good opportunity, not just for work, but to promote the education of PCBs. With that said, we're going to get into, and again, this is an awareness level. We're going to look at some concerns for working with this stuff, a little bit of, hierarchy of controls, how to protect yourself from it. But we really get into this in the worker class because we want to actually give some field usable skills so that we know that any of our participants are going to be qualified to do work after a worker course. That's why I'm kind of shocked, that even like Massachusetts with Wayne's example with the Massachusetts, was it the MWRA, the wastewater? Yes. Having only a 4-hour course is ridiculous. Take a 4-hour course and then abate his PCBs. And we know, through the literature that it's just as toxic, if not more, than lead and asbestos, right? And you have to have a 32-hour worker course to abate those. So why is a 4-hour awareness course okay? I don't know. Who knows? Anyway, so again, let's have this interactive. If you got questions or stuff as we're going through it, please bring it up. We will end off with an activity again. like we did. And then tomorrow we're going to reconvene. I think, Manisha, you said that we'll do the survey tomorrow. Is that right?
Today would be
Oh,
fine.
today. Okay, we'll do it today. Good thing I asked.
I posted a comment in the chat if anyone needed help finding the survey.
Oh, you did. Okay. Perfect. All right. So, so to address worker and public risk, you know, you want to be able to do sampling. You can also do this to meet, you know, certain regulatory requirements at the either federal or state or local level. And by the way, there was a number of hits that came up when I searched for, you know, testing requirements on different state levels. There's a fact sheet underneath Wisconsin state government. They don't require it, but it's very well worded about, you know, advising, recommending that any project done on a building of such and such a date that you test for PCBs because of the problems that could happen afterwards. You know, so, you know, again, you know, look at the state level first. So there could be some requirements there that you might either have to follow or is recommended. You know, we want to look at worker exposure. Obviously, we want to make sure that they're not getting exposed at levels that are harmful. And in this industrial hygienist opinion, that's anything over 0 ppm because of how toxic this stuff is. You can just generally test for indoor air. And that's one of the ways that they actually find that a school has too much PCBs in it, because they'll just go in, they'll do an indoor air sample, area sample, and they'll find that they've got PCBs that are way above what a background level would be. And so the only explanation is they've got contaminated material with PCBs. You can look at outdoor air, you can take bulk samples, so you can, you know, take something from, you know, pieces of caulking, you know, building materials where PCBs might seep into, like surrounding concrete brick, things like that. You can also do wipe samples and also impacted material, as I just mentioned. So there's a bunch of different ways that we can sample for this stuff. Again, I will just say though, if we're doing personal exposure sampling, it's got to be done by that 5503 NIOSH method to comply with the OSHA PEL. You want to make sure that you can get information out, you know, to workers, to the general public. It's a way to cut down on liability because you're giving people information up front. You're not doing it after the fact, after somebody got caught with their fingers in the cookie jar. So, you know, and there are some requirements about PCB labeling. Unfortunately, you know, we might need some medical evaluation analysis of what we've got for levels of PCBs. They can do blood analysis. And unfortunately, the farther down the road part of that is medical screening for disease. Just like you can take a chest film for, you know, for asbestosis or mesothelioma, you can do medical screenings as well for PCBs. Unfortunately, what's the downfall of relying on medical disease screening?
It's after the fact.
Yeah. What do you mean after the fact?
The damage has been done already.
Yeah, the damage has been done. At least with blood analysis, we can see, you know, a level of a toxicant creeping up. But once you've identified disease, you know, most of our organs, our systems can't recover well from a disease, you know, and leaving it alone up to medical intervention and treatment, I mean, you're rolling the dice, right? So we do have this as a tool, but it's not my favorite tool. My favorite tool is upfront identification of the stuff and then implementation of the hierarchy controls along with worker exposure monitoring. If we do all that well, we shouldn't have to worry about these other two things. And maybe we just, you know, look at blood analysis as a catch-all, right, to see how we're doing. You can abate or mitigate. So abatement basically, you know, involves removing the stuff. Mitigation means you're going to leave it in place and prevent its degradation somehow or contact from the public. And again, if you're doing any of this stuff, you know, with PCBs, you want to make sure that we've got the right controls in place. As we said the other day, this stuff is absorbed through the skin. So we do not want to do any work around potential PCB material with unprotected hands or skin. Exposure controls, again, follow the hierarchy of controls. That is the ultimate practice of industrial hygiene after we assess. Engineering controls first, followed by work practices and implementation of PPE. Basically, it's similar to lead and asbestos. You're going to see, if you take the worker class, we're going to be repeating a lot of the skills that we do in the lead and asbestos as far as mitigating the fugitive emissions, cross-contamination, things like that. HEPA vacs, and tools that can control dust should be used. No dry sweeping, never a good idea. And we might not be able to get, exposures down to a level that we're comfortable. So we also, in addition, might need to wear things like respirators. Even with engineering controls, like I said, we want to make sure that we're wearing, P100s for aerosols. If you're going to be heating PCBs or using solvents, again, we're introducing a different type now of hazard. It's not just in particulate form. We're going to be volatilizing the PCBs, and you're going to be working with chemicals that might be volatile. So we want to be able to capture those at the, at that type of level. So we're looking at not just a HEPA filter, but we're looking at an organic cartridge as well. Again, splash chute gloves and booties. No matter what, even if you would have zero airborne exposure, you still don't want to get this stuff on your skin. And with that said, not all chemical protective clothing is going to act the same. So butyl rubber and neoprene, good against PCBs, and natural rubber, latex or nitrile, not so good. So you want to make sure that, contractors, when they've got their PPE program, and remember, it's a requirement under either 1926, the construction standard, or general industry, there's got to be an assessment of a hazard done, why you're wearing this stuff in the first place. And it's got to be done by a qualified individual. And the standard outlines that. More often than not, I have worked with contractors, construction contractors after the fact, where they had someone who was not qualified, put some of this stuff into place, and they selected inappropriate material for workers to use. And so here you've got, a guy or gal out there, doing their work, and they think they're protected. And in all, actuality, they are not. So again, just another good benefit that we can do as health and safety trainers and promoters of this stuff out in the field, especially if you're also wearing an additional title of, local union health and safety rep. We can help educate our contractors on making sure we've got the right people doing, putting together these programs. Again, an employer just can't throw some gloves and something like that at somebody. There's got to be a written program in place that was done according to the standard to make sure that workers are protected properly. Bonus question, anybody know who this is? No. Wayne, you can't answer. It's Wayne. One of the things about creating a good curriculum, the way that I put together, is I need good photos. Sometimes I cannot find good photos about something. So Wayne was very gracious in the lending of his likeness so that we could take some good PCB photos. He will sign autographs, by the way, but I think the charge is up to $50 a signature. You got to bring your own photo. Does that sound fair, Wayne? You're on mute, buddy.
Can I just get an initial then? What's the cost on that?
I'm not getting much interest in it, so I've dropped the price, Bernie.
That's because you don't have the right manager, man. All right. How do you protect yourself and your family? We've mentioned this a couple times, and it's the same thing with lead and asbestos. We do not want to be bringing this stuff home. If it's possible, we want to leave our work clothes, at the work site. In addition to, if we had on a protective suit or something like that, it's still possible for our underclothing, our street clothes or work clothes to get contaminated. It's a good idea to have a change out area to be able to do this after you were decontaminated and you took off the protective layers. Again, there's a bunch of ways that we can do this. One is we want to make sure that we've got a sound plan that was developed to make sure that not only are we abating the material and then making sure that we are categorizing it, packaging it up, getting it ready to ship out. But that we're also making sure we're decontaminating ourselves and all the tools that we use properly as well. Hazardous waste sites or heavily damaged structures, contain a type of a different PCB risk, and not just for this, but lead and asbestos. So one of the avenues that I'm interested in for the IUPAT is, doing disaster site work. So we're having so many natural disasters now, one after another, year after year. This year was another record breaker for hurricanes. But a lot of this stuff damages, surface finished materials like, wallboard, flooring, stuff like that. It makes sense, for IUPAT folks to be involved in this if they'd like. One of the caveats of that, though, there are different unique hazards here. So now we've got an uncontrolled site. It's not like you've got that Capitol building where, the caulking is on the outside of the building, it's there, you can see it. This is different. You're going to walk into something that was destroyed. So you've got a chaotic environment. It's considered uncontrolled under the HAZWOPER standard. And under our emergency response framework, the national one that is under DHS and FEMA, this is actually cited. If you're going to do disaster work, they want to make sure that folks are following the HAZWOPER standard for post-site disaster work. Again, if you're responding to something like this, you got to think about what the age of the building might be that you're going to do this post-disaster work in. And again, let's say if you're not, if our members aren't doing the actual post cleanup work, you're just going to go in to do, the repair, right? Put new wallboard on, new flooring, stuff like that. Who knows how the prior people did the cleanup? I can tell you because I've been involved with a number of disasters through the feds, through NIHS, which is one of our grantors for our CPWR grant, where we do like HAZWOPER training and stuff. It can be very, plus or minus quality. You don't know who's going to go in and be doing this cleanup work. So, and they're not necessarily going to go in and test to make sure things are free and clear of this, that, or the other hazard, which is unfortunate. And a lot of times, depending upon what state you're in, there's going to be waivers for waste disposal for the stuff. Now, there are some tried and true methods, like, for instance, we've got the white material here. We call it refrigerators, washers, dryers. Those need to be segregated and things like that. But when you've just got a pile of rubble like you see over here, that might get a waiver. And so if whoever came to doing that disaster cleanup didn't do it well, if they're just ripping and skipping, as we say in the criminal asbestos world, you don't know what you might be walking into. So here you go, as an IUPAT member, you're thinking like it's a regular, kind of job. You don't need to have a higher level of protection. And that might not be the case. So things to think about, when we're doing this kind of work. That's why it's nice if we can manage it ourselves, from start to finish. Just thoughts of an industrial hygienist anyway. If it's determined that caulking materials contain PCBs, a site abatement plan should be developed. EPA does have a recommended method for doing this that covers public health concerns, making sure you don't have fugitive emissions from that stuff. And we outline that in the worker course. You want to make sure that you're using tools that can capture the material. This is an example of a vacuum capture device that's on this knife. Just a couple other examples.
Like something my dad made.
This one here, I was pleased to see this. This is out of Wayne's training center. This is a nice DeWalt. Oh, I have those 20-volt max batteries. Okay, those are not cheap, by the way. Just the battery. The tool is like $5. The battery's $200. This is a really nice one. It works well. It's a way to do, I can't remember, Wayne, if this was a drill or a rotary hammer.
It was a hammer drill.
But it was okay.
Yeah.
But it's nice because it works. So, as you're doing your boring and stuff, it's going to, capture the dust It comes down here in this nice little compartment. It's got a HEPA filter there, and you empty that out into the appropriate container after. So look for different methods like this if you're doing work where PCBs might be there.
Our guys use those hammer drills with the little HEPA filter and everything like that. But then afterwards, they take it out.
Oh, yeah.
So, and I don't think it's ever been clearly told, hey, what are you supposed to do with that afterwards? So they're supposed to pack it up, correct?
Yeah. So think of this phrase, start to finish or cradle to grave, as they say in RECRA. So if you did everything right to protect yourself, you use that tool to make sure you don't, create a lot of fugitive dust and things like that. And then you go and you expose yourself without your respirator on, without a suit on, right? You might have protected the public, but you just put yourself in potential jeopardy. So yeah, that's a really good point. You want to make sure, and again, if you know that it's a certain material, it might have to go into a certain waste stream with certain packaging and labeling. So you want to, behave like this stuff is what it is, and you don't just want to go and make a dust cloud. So that's a very good point. All right. So here's some case studies that I just wanted to show. This is a Martson water treatment plant, and again, you're going to find this stuff in all kinds of buildings. PCB was in caulking. The caulking removed, but underlying concrete was contaminated by it, and it had 1,000 ppm of PCBs. That was the level of contamination in the caulking. Uh-oh, why isn't my mouse working? This is UMass Amherst. PCB was found in the caulking. It was removed, but underlying concrete was contaminated. Again, 1,000 ppm. This was a huge project. Samples ranged from 1.4 to 7.4% PCBs, which is 1% is 10,000 ppm of volume to volume. So that was a significantly high concentration of PCBs in the caulking. This job right here on the left is not for me. You can see how far the ground is down there. That looks like it would hurt. Bernard and heights don't work well together. I can help you protect yourself from them, but just don't ask me to come up there with you. Another university here, Rhode Island. This is in 2000. They did this project. PCBs was found in the soil from caulking, breaking down and getting into the soil. It was 600 times above the EPA limit, and we said the high limit was 50 ppm. So let's see what we got there. It's a lot of zeros. $30,000 ppm of PCBs in the caulking. EPA mandated the cleanup. So here was a thing where EPA said, look, we found that there was PCBs there. We know it. We know that your soil was contaminated. So this is what you're going to do to fix it. And the project was a year, and it costed over $3 million to do. And one thing to think about, the higher concentration that you've got of PCBs in your material, whether it be caulking, paint, etc., we know it's volatile. What do you think is going to happen to the airborne levels of PCBs within that indoor environment if the concentration goes up in that material? Another way to say that, let's say you got PCBs in caulking at 50 ppm compared to 30,000 ppm. Which one is going to be more detrimental to the airborne levels?
30,000.
Yeah, the 30,000. The higher it is in the material, the higher it is going to be in the air.
And that's just from dust buildup and wind, or?
No, not dust, from it off-gassing. So remember we said that these are volatile. So they are going to off-gas, and because they are so persistent and so good at not being volatile, it's going to take place over decades. So many, many years. And again, if we don't abate this stuff, 100 years from now, it'll still be off-gassing. That's how persistent they are. However, as far as the dust is concerned, let's say if you are doing something that creates dust, like maybe you've got a building maintenance person decides to sand something, right, to repair, or they're doing some repair themselves, they create dust, they're going to have that avenue as well. So then you've got, air, vapor in the air, as well as whatever that dust was until it settles. Good question. All right, so that's the end of that module. Any comments or questions? Where is my activity? All right. Now, this one, this module is the shortest of them. It's not the intent to make, participants in this awareness class experts on implementing these controls, what the health monitoring components are, things like that. But we want to make sure that we give them enough at the awareness level where now they understand what PCBs are, what they do to you, where they're going to likely find them. So now, at least if they're out on a job, they can identify that stuff and say, this is strange. I know nobody's tested the caulking here. We're not wearing gloves or respirators, yet they're asking me to take out, 5,000 linear feet of caulking. I think I should probably tell somebody about this. All right. So what I'd like folks to do is, Manisha, if we can put everybody into groups again, as we did. We'll give them 20 minutes for the group work and then bring them all back and go through the, oh, you know what? We don't have a case study, do we, Wayne?
No, it didn't come up.
And you know what? We did, you guys covered this when I was not present because I was deep sea fishing, if I remember correctly, back in July during this day. What did you guys do? Because I don't want to.
I can't remember what I did yesterday, much less what I did in July.
Well, you know what? It seems to me that everybody is in front of a computer right now, right? Why don't we do this? When you get to the questions that require the use of a case study, try searching up a case study about PCBs. Chances are you're going to be able to find one right away about a school or something like that. I mean, you could even type in the couple that I had up there, like from UMass Lowell or University of Rhode Island. Just together try to find a case study on the internet to to talk about it, to answer the questions that concern a case study. How's that sound? Boy, if that's not thinking on the fly. All right. All right, Manisha.
How many minutes, Bernie?
20 minutes, please.
Okay.
Actually, you know what? Let's give them 30 so they can find a case study. Give them an extra 10 minutes to find something and review it together.
Okay. All right, no problem. All right, Bernie, I'll be right back, okay?
Sounds good. All right, folks, let's just go through this as we have done the other ones. And then what I'll do is I'll turn it back over onto the slides because we've got a summary slide. And then if there's a knowledge check that was put on, I don't know if it was a requirement for the LMS or what, but, I guess you can choose to do that or not if you're delivering the class. All right. So number one, list 3 types of PCB sampling and state what they are used to determine.
Oops. I don't like that.
Oh, you're on mute.
You're on mute, Dave.
Okay, I got NIOSH 5503 for air, personal air sampling.
Yep.
SW 846 for method 9079 for oil. SW 846 method 9078 for soil. Then there's bulk, wipe, impacted material,
Good.
indoor, outdoor sample. There's a lot of them.
Good. Now let me ask you this. Which one of those would you need to determine if a worker was exceeding the Pell?
You'd have to use a personal air monitoring.
Good, good, perfect. Anybody else have anything they'd like to throw in there? That was pretty good. All right, number 2, discuss and describe the difference between abatement and mitigation and when each should be used.
Okay, we got abatement is removal. Usually that's for smaller areas that you can take out and get rid of. And mitigation is making sure nobody can get to it, and that's for larger areas where you're going to encapsulate or cover with something else.
Well, that's right. That's the definition of those two. But don't get hung up on the square footage or linear feet or anything like that. It really depends. Who's likely to come in contact with it. If it's significantly damaging, the air environment, or I should say, off-gassing to the air environment, what the condition of it is in, what the use of the building or area is. But one, you leave it in place. You try to, as you said, prevent people from contacting it or prevent it from deteriorating. The other one is you're removing it altogether. All right, good. How about number 3? List and describe 2 medical evaluations used to determine a worker's PCB related health risk.
We got blood analysis and medical screening for disease.
Yep. Good. And again, as we said, preferentially you want to look at, blood first. You don't want to wait to try to catch a disease because then you've already got a disease. And even before all that stuff, let's implement the hierarchy of controls. Let's see, 4, agree or disagree. If you are using engineering controls to reduce your exposure to PCBs, you do not need to use PPE controls.
I guess that depends on how good your engineering controls work. Reduce it to below the recommended exposure level. NIOSH's level, you don't need it. But they should stay in place. If you can't, then I would use PP anyhow, just to be safe.
Okay. Anybody else have anything they'd like to add? Remember, we mentioned one specific example, even if you've got engineering controls to reduce airborne exposures. If you're removing the stuff, it's a skin hazard, right? So you want to prevent it from contacting your skin. So you'd at least probably wear the appropriate kind of glove to make sure it's not contacting your skin.
I mean, off-gassing, if you're right next to it, you might want to use respirators too.
Yeah, right. Okay, describe how you can protect your family from PCB exposure if you work with PCB materials.
We got, make sure there's a decon trailer so you can shower, change your clothes.
Yep, good.
Treat it as lead, basically.
Yep.
Yeah, that's right. I mean, it's pretty much, you're going to see in the, if you do the worker class, controlling this stuff is similar for most instances as lead asbestos. There are some differences for packaging, things like that. Labeling, obviously, the regulations are different. Asbestos doesn't migrate into other materials like this does, et cetera, but it's pretty similar. Let's see, so what did folks get for a case study? Anybody find a good one?
Yeah, we did.
Okay, what do you got?
It was called Try Something Environment. They did a job on a school, and
Triumvirate Environmental in Massachusetts Public School.
Yeah, they're a big waste hazardous waste company. They dabble in abatement, things like that. And, yeah, like Clean Harbors, you might have heard of them. All right, good. So that was your case study. So was PCB an exposure concern
In the public school, yeah. So they had it in about 120 light ballasts. I'm just kind of reading it off of it, so it's tracked. Around the windows, caulk. So building materials had PCBs. So they had removal and remediation in both cases.
Okay. So there was more than one type of building material, which again is typically going to be the case. And I mean, you can even run into situations where maybe they went through and removed light ballasts, but all caulking and coatings left behind, still contain PCBs.
Well, they did say on here that they removed approximately 120 leaking light ballasts before retesting the air. So when they retested, it revealed that PCB levels were still high. It became apparent that PCBs were likely present in building materials.
There you go. There you go.
They said he was
Good work.
present in caulking around windows and construction joints, both outside and inside the building.
All right. Yeah, see, I mean, you see how these pieces of the puzzle fit together? I mean, it's now that we know, we can figure this stuff out. But yeah, that's a great example, Nuno. Is it Nuno or Nuno?
No.
Nuno, okay.
Some people say no. I just say yes.
I'll say no. Now you got me. Now you got me tongue-tied. Don't ask me to say that 3 times fast. Nuno. Okay. Let's see. What materials that would you be working with or near are PCB exposure? Oh no, we already did that one. Should your employer determine your personal PCB exposure for this this case study you got? What do you think?
Yeah.
Absolutely.
Yeah, I mean, I would say, especially with the fact that you stated after the ballasts were removed, they went back and said that air levels were still high. Absolutely.
Yeah, we said that they should use historical data. Anything before 1980 should be suspect.
And with what you said, I mean, this is a very clear case where the employer better be doing exposure assessment for workers, because this would directly, you know, not only fall under the general duty clause, but it's obvious that you're going to have to compare air samples here to the Pell, right? There's already data on air sampling. So, you know, that would lead you to believe, all right, if they're not just walking through the building, they're going to be removing this stuff or working on the material.
Right.
It goes to say, with reason, right, that you're going to probably be having a higher exposure than what you're already seeing just walking through the halls there. So, all right, good. List engineering, administrative, and PPE controls that you would like to see used to reduce the worker risk.
Well, we got glove bags. You could, if you needed it, if you could. Containment, negative air with HEPA filters. Housekeeping, no dry sweeping. Respirators with HEPA and organic vapor because of the off-gassing.
Yep.
Yeah.
Good. And one of the things too to consider is a written plan, right? Now, yeah, we want to make sure that the contractor has developed a written plan, not just about how to protect the public and the environment, but how are they going to protect workers with all those controls? Research and list chemicals that may interact with PCBs synergistically. What does the word synergistically mean as far as chemical toxicology?
That's the wrong one, Bernie. That's not the next question.
No, it's not.
It means it would be more than one time the amount. It would be a.
The next question we have is,
Will you need to be concerned when managing the construction waste as PCB regulated waste, and why?
Huh. It printed out a blank page for me. All right. Okay. So how about you answer the question you just read? Thank you.
So the employer should be, because he's the one that's really responsible for disposal. But if I have the right PPE on and engineering controls are in place, I would be protected.
Mhm.
we put yes if it tests over 50 parts per million.
Well, that's F, isn't it?
Yeah, if it's lower than that, then it can be thrown in the regular construction waste, I believe.
Yep.
Let me ask a question, guys. Is the co-generator in effect with the PCBs like it is with lead?
It should be.
Oh, Jim just asked the ringer question, I think.
If you're working with it, if you're taking it out, then you're the co-generator, and the person that owns the building is responsible for it too.
That's right.
Okay, it was a different thing you're asking, Jim.
But the co-generator is responsible for the waste.
Right.
All right, do we have another question?
List some general PCB waste requirements. If you determined that the waste is PCB regulated waste, or if it is not a PCB regulated waste, how may you dispose of the waste? And we put if it's under 55 parts per million or 50 parts per million, it's not a regulated waste and it can be just thrown out. And if it's equal to or above 50 parts per million, it's got to be put in a landfill, incinerated, a high efficiency boiler.
Good. A PCB license landfill.
Oh, and it, or it can be treated, you said, with, to make it non-hazardous. I don't know how they do that. They take the chlorine out of it, or?
I'm not familiar with the
Yeah.
process, but yeah, they're basically going to chemically inactivate it. What else we got? What's another
That's it.
question?
Yeah.
That's it? Okay. Now, something that I thought Jim was going to go with this. So let's say if you've got a mixed waste of PCBs, asbestos, and lead, which one of those is going to govern how it's disposed? Is lead more important, PCBs more important, or is asbestos
I would
more
say.
important?
Asbestos? Yeah.
Jim, you want to take
Yes.
this one since this was your brainchild?
Talking with the EPA, PCB supersedes all waste.
Wow.
Yeah.
And then there's only 4 places in the United States that will actually take it. It supersedes all of it. Is that right,
Yes.
Bernie?
Yep. Yeah. So we actually have a letter from the EPA that speaks to that. So it can be quite expensive. You know what I mean? Especially if a building owner or project manager didn't do things appropriately and they made more waste by weight than they should have. It's going to be very expensive because now you've got to dispose of that as a mixed PCB waste, and that's a lot more expensive if you just segregated the PCB material out beforehand. So there's a lot of good reasoning why we should do things the right way. Go ahead, Jim.
Also, Bernie, if you're doing an abatement job or if you're doing a paint job, you can't, even though it comes back negative, it still can't go in a regular landfill. It has to go to a industrial landfill because it is
PCB
part of a
approved
job.
landfill.
Well, if it's
Yeah,
non-PCBs, or it has to be a PCB approved if it has PCBs in it. If it doesn't, it's still got to go to an industrial landfill so it can be tracked.
Yeah, and all this stuff's going to fall under the RECRA rules, cradle to grave, from generator, to shipper to ultimate disposal. And again, in the worker class, we get into that. We actually have an activity where the participants are going to fill out, waste manifest, determine how you package it, things like that. So, okay, any other comments or questions from that activity? Seeing as none, so I'm just going to move on with the rest here. So this is a summary. A lot of PCBs out there, still present in the environment. Definitely, this poses a health risk, to our members. And there are a lot of different agencies that have a component of regulating these out in society. This is just the knowledge check that they've got. I think Dan Jr. put this together. So we've got a couple of different, questions. I would go ahead and use this if you're delivering the class. A lot of the stuff are things that we covered well and were part of an activity that we did. See, I think he's got 20 questions. 15 questions.
That's actually what
And
we
that's
did
it.
that last day, Bernie.
Oh, okay. Oh, well, I'm glad I went through them quick then. We'll do them the last day. Any comments or questions before we close out today? We're going to get together tomorrow.
I was just wondering, you said PCBs supersede all the other waste. Does that mean that you could just, well, you did say you should separate them so you don't wind up with more than So
Yes.
are they more expensive to get rid of then?
Yeah, yes, yeah,
Oh, yeah.
because if you think about it, there's only a handful of places to bring PCB waste. It's going to be more expensive. And so if you're, developing a waste that's not segregated, and it's a lot heavier, it's going to be a lot more expensive.
I know
I'll
if
see
we
if I
do,
can't come up with some costs for tomorrow.
like asbestos work on a bridge, it's a lot of waste because we can't recycle it. We have to use Black Beauty to do that.
Yeah. Any other comments or questions?
Yeah. How soon are we okay to go ahead and hold this class here at our place? I have
Do you mean,
industrial guys in here all winter, so those would probably be good guys, apprentices to give this class.
as
So it
soon
can be
as
as soon as next week.
as long as you're implementing your COVID controls for your training center whenever you want. And,
Okay.
feel free to reach out to me, Wayne or Jim, if any questions come up during it.
Okay, thanks.
Absolutely.
That
Yeah.
kind of leads me into my question. What is your guys' recommendations on how we continue to roll this out? Do you think we should be bringing it to the apprentices, journeyman upgrading classes? We just need some feedback on what you think.
I think apprentices would be a good start, especially for us that haven't taught it before. Just, as sheer practice. But it's going to be weird for us with the COVID thing, with all the journeymen coming in, because we're used to having hundreds of guys in this building at this time, pretty much at any given day for all their research and things, but we're not able to do that this year. So we're having to sporadically bring them in a few at a time. And it might be hard to do it with the journeymen. With the apprentices, we have a set number we can have here in groups. So it may be easier to do it that way. At
Well,
least
hearing you
for the
say that,
start.
Justin, do you think there'd be a need for us to run like one of these classes per district council?
You mean
Yeah.
through Zoom? Yeah, I think that would be a good thing too, because that would be able to get more people at once. Because I think we're doing groups with the journeyman coming in, we're doing groups of 8, I think, so that we have room in each room for instructors. Because in Ohio, we're limited to 10 people in a group. So we sometimes do have 1 or 2 groups at a time, but we keep them on different ends of the building. And then we take breaks at different times and things like that to try to keep everybody separate. And we're sanitizing all the time, like everybody I'm sure is. But yeah, I think to get a big group of journeymen on a Zoom or a couple Zooms, I think would be good, because we have a huge number of industrial painters in our district council, being as we include Youngstown. So you guys know Youngstown's kind of, that whole area, Youngstown, Pittsburgh area is like the hub for the bridge guys for some reason.
Yep.
Okay, and we can talk more about that, doing this tomorrow. I think this is a good start, because we really would like to get this out. Knowing that we know what it is, we got a course on it. Doesn't do us any good to keep it under wraps. So the better way we can get that out, love to hear it. With that said, if there's not any other comments or questions, I'll turn it over to Manisha, if you want to discuss the evaluation, or what are we calling this thing?
The end of course survey.
Yes,
Yeah, just make sure you all take it at the end of the course. You can take it today, and then it will show up as completed in the LMS. So I'll run the report tomorrow for you, Bernie, and I'll send out the results once everybody gets that.
Is that going to be just like the end of course thing that most of the courses have?
Yeah, same one, just the online version.
All right. Well, otherwise, we'll see everybody tomorrow at 10 for our last bit of discussion, and it'll probably be about 45 minutes to an hour, something like that.
All right,
All right, everybody. Take care.